Solution to the practice problems, both decomposition and partial differences. Decomposition, 60 plus 6 plus 2/10 plus 1/100th plus 3/1000ths. I'm subtracting 5, so notice I lined it up in the ones column. I'm subtracting 1/10, so it's in the tenths column, and I'm subtracting 8/100ths. There's nothing taken away from the 60. 6 minus 5 is 1. I have a whole 1. It's positive. 2/10 take away 1/10 is 1/10. 1/100th take away 8/100ths leaves me in the whole 7/100ths. And 3/1000ths take away nothing is still 3/1000ths. We're going to kind of do this in a couple pieces here. 60 plus 1 I know is 61. If I have 1/10 and I'm taking away 7/100ths, I have 1/10 and I'm taking away 7/100ths. I need a common denominator, so I would multiply by 10, and I would get 10/100ths minus 7/100ths, which would be 3/100ths, which would look like 3/100ths would look like 0.03. It's in the hundredths position. Now, how else could I do that? You ask yourself, you have 1 dime and you're going to take away 7/100ths. So you want to think money, and you'll end up with, you want to think money, so you'd say 1 dime is 10 cents. I'm taking away 7 cents. I have 3 cents left. Again, this 1/10 is 1 dime or 10 cents. I'm taking away 7 cents, so I'm left with 3 cents. And then the thousandths in terms of money is awfully difficult to think of because we don't go that far out with our change. So my answer here would be 61, no tenths, 300ths, and 3,000ths. So in order to say that, I would say 61 and 33/1000ths using partial differences. Notice again the decimal lines up, taking no ones or no tens away from the 6, taking 5 ones away from the 6 ones. 2/10 take off 1/10 leaves me 1/10. 1/100th minus 8/100ths leaves me in the whole 7/100ths, and put that placeholder in there again, because remember the 18/100ths is the same as 180/1000ths. They look different, but they're equivalent. So 3/1000ths take away nothing would still leave me with 3/1000ths. So finding what we have here, I would do it actually in 2 steps. I would take the 60, add 1 is 61, add 10 cents is 61, and 1/10. 61 and 1/10. We're going to take off the 7/100ths, so that's going to leave me 61 and 3/100ths. And then when I add my thousandths, I get 61 and 3/10ths. Excuse me, 300ths and 3,000ths, which is 33/1000ths. Next problem, using decomposition. 20 plus 1 plus 8/10ths plus 3/100ths. Make sure you put your decimal in the appropriate place. I'm going to take away 10, 5 ones, 8/10ths, and no hundredths. So 20 minus 10 is 10. 1, spend 5, I'm in the whole 4. 8/10ths, take away 8/10ths, I have no tenths left. 300ths, take off nothing, I still have my 300ths. Combining, 10 minus 4 is 6, plus the 3/100ths. And so 10 minus 4 is 6, I get 6 and 3/100ths. Using partial differences, 20 minus 10, 21 minus 10, because I'm in my tens column. 20 minus 10 is 10. In my ones, 1 minus 5 is negative 4. So right there, we know that that totals 6. 8 tenths, take away 8 tenths, leaves me nothing. And in the hundredths, 300ths, take away nothing, leaves me the 300ths. Notice it's positive because I still have it. I'm not in the hole. In the last problem, using decomposition, I have 700 plus 80 plus 5 plus 5 tenths plus 1 100th. I'm going to take off 500, 90, 3, and 3 tenths. Hundreds column first, 700 take away 500 is 200. 80 minus 90 leaves me in the hole 10. 5, spend 3, I still have 2. 50 cents, take off 30 cents, or 5 tenths minus 3 tenths leaves me 2 tenths, and I still have that extra penny or hundredth. 200 minus 10 is 190, plus 2 is 192, 2 tenths, and 1 hundredth. Using partial differences, 200, 80 minus 90 is in the hole 10. 5 minus 3 is to the good 2. 5 tenths, take off 3 cents is 2 tenths. And 1 100th, take nothing away, is still 1 100th. What you got to worry about is that negative there. This is 190, and the 2 with the 2 tenths and the 1 100th is 192, 2 tenths, and 1 100th.